Hi everyone, this is one of my occasional now videos on the belly tank racer that I built. I was inspired by an episode of Superfast Matt where he fed his CAD model of his land speed record car into an online wind tunnel simulation, and I thought, well, I could do the same thing, but to do it with my car, what I would have to do, because it wasn't designed on a computer really, was to scan it with a 3D scanner. So recently, we swapped a resin printer for a 3D scanner. Now, this scanner is not the absolute latest generation. It's about 2 generations back, but in its day, it was a pretty expensive machine. So we'll go to the unit and try to scan the car. Now, one thing with 3D scanners is they don't like a shiny surface. So seeing as my car is entirely made of shiny aluminium, we have to spray the car with a special spray that makes it non-reflective. There are special sprays for this, but they're £20 a can. And apparently a friend of mine who does this a lot at a job he has at a university says that you can use Batiste original dry shampoo, which is a lot cheaper per can. Apparently this is what they use. It's not obviously officially meant for this purpose, but of course you can wipe it off pretty quickly from your car. So let's see how we get on. Smells nice.
Old deodorant.
God. This looks like it's we're making some Christmas scene, doesn't it? We've done half the car and we've got through 2 cans of magic spray. So what does it look like? Well, it's not like spraying paint at all. It obviously doesn't stick as well as paint.
So it does come off again, though.
But it does come off again, yes. This is now 4 cans.
Well, I mean,
pretty much 4 cans of Batiste. So while Nick is spraying the car with dry shampoo, let's jump out for a moment and take a look at some of the data from my runs on Pennine Sands in September. These reveal my rather rubbish driving technique, particularly my poor choice of gear changes, and it does give a few pointers to how I might improve this next time. So here's the data from run number 1. You can see I go up in first gear, then there's a long gear change, and then I accidentally go into third, so I'm at 1000 RPM, slowly accelerating. So that's completely wrong. I then go into second and then suddenly, boom, engine screaming, get a bit more speed up, then back into third at about 2,500 RPM. And then I run out of room because I've gone through the flags. So that's the end of that. So a good learning experience, but not really much performance. And you'll notice the temperature goes from about 32 degrees to about 42 degrees. So about a 10-degree increase in temperature on the run. So a complete run and return is about a 30-degree increase. So I'm gaining 20 more degrees on the return run. So this is run 2, which is a lot better. You can see I've got a consistent increase in speed. This GPS only records about every 7 seconds, which is where you get the stepwise pattern there on the speed. But you can see I get accelerate 1500 to 2500 RPM in first, good consistent increase in second. I think my RPM reading is overreading because I'm taking it from the alternator pulley with a fudge factor built in, but my fudge factor might be wrong. Then third gear again, only about 2/3 throttle there. So where would that have reached if I hadn't run out of distance and hit the flags? You can see there, that's where the flags were. So what would have happened if I'd gone up through first and second faster and done snappier gear changes? I might have got into third earlier and then probably would have done better. Again, you can see a roughly 10-degree increase in temperature during the run, plus another 20 on the slow return run to the pits. So I could always get towed back to the pits. That would save me 20 degrees. So here we are again. So let's imagine we floor it in first, get up to about 4,000 RPM, and then I can get into second, not at 1,000 RPM, but at something higher, maybe 2,000. So we get up there to that point earlier in time, earlier down the course, then into third again at a higher speed, and then up, which gives us consistent acceleration and time to get to a higher top speed. You'll notice that I was accelerating all the way to the line. It wasn't tailing off, it wasn't flattening off. The car's obviously fairly aerodynamic, hopefully. So it's all about how fast I can get into third, really, before I run out of distance. So a reasonable target for next year might be 80, high 70s, 80. Seems perfectly reasonable, I think. Beyond that kind of speed, I'm just going to need more power, because at the moment my engine is completely standard. We've concentrated on the one side because, as I say, we can flip the scan if it's successful. Well, it's very Christmassy anyway, Nick.
Christmas.
Yes. Right. And they've got these lights like this shining at the roof because we want diffuse light.
First test scan there. So what you can do, this is just a preview of the point cloud. You see lots of points there.
Yeah.
So if we go to Fusion now, point distance, yeah, that'll be fine. So let it process, and then suddenly you'll get a lot more detail. Maybe I've got it a bit too fine. I should have had it at 1 millimeter or more. Make it coarser. There we go. So you can suddenly see your fixings and retro-affected dots and things.
Yeah.
So we can get rid of all the random stuff that we don't want just by isolating. Basically, it sort of knows the biggest thing is probably the thing you want to scan. Anyway, so that was a bit of a test scan. So if we go to... That was a test scan as well.
Oh, that's pretty good.
So it looks like we might have some misalignments there, like that. We've got a few striations and things there where it's a bit glossy.
Yeah.
And we've got some holes where we've got the dark, where you've got your logo painted on the side.
Yeah.
But we can fuse that all together. See this one, we've got misaligned frame.
Yeah.
There.
Yeah.
So if we fuse that now, it might correct it, it might not. On more advanced softwares, you can go through and delete the misaligned frames with this. Hopefully it doesn't stuff up your air filter.
Yeah, that would be nice. So we need 10 cans of spray, and we need to come back and do the wheels, but doing okay with the bodywork. Right. Oh, so Nick. Well, it was pretty coloured.
Yeah. So the different scans, and they, as you can see, this computer is barely capable. But the different scans, they overlap. So what we want to do is stitch the scans together in a way where the computer can recognize the overlapping geometry, and then it will be able to ping the scans together. Now, what can sometimes happen is it gets confused, and so you'll end up with things the wrong way around and stuff, and you can do a manual alignment on that. So as you can see, we've pretty successfully managed to scan one side of the car. So that's actually already been processed together. So if we just get rid of that, Excuse the slow computer. So this was one I did earlier, but as you can see, we've got a little bit of a problem on the back here. So we've got some misaligned frames. So we're trying to stitch it together in a way where we don't have any misalignment.
But it's getting better, isn't it?
But we've got pretty good detail around the roll cage. You could very easily add wings onto this. Yes. It'd be an aeroplane. Yeah. A Mad Max aeroplane dangled up from the Christmas tree. Yeah.
I'm amazed how well it's got the tubes around the roll cage now, actually.
So, yeah, that silver scanned pretty well. We've got a bit of the seat in there, and we've got a few more things to add in. So what we'll do is when we've got the proper matting spray, we'll be able to go down low. We're going to take the wheels off the car because that prevented us getting, because the scanner has to scan within a range. If it's too close, it won't scan. If it's too far away, it won't scan. So the wheels were interfering with that. But we've got we've got.
So I'll sit in it next time as well.
Yeah, we'll have John in there.
I'm part of the aerodynamics. Or lack of.
So we've got the front of the car, we've got the windscreen, we've got the sort of detail around the engine cowling and stuff like that.
So is this finished? You've got a bit more. You said you've got a bit more on the other side.
Yeah. So hang on,
So I'll come back in a minute, shall I? So I hope you like this video. As you can see, we're getting there. So before part 2, I need to take the wheels off, buy probably 10 cans of Batiste spray, who are not sponsoring this video, a couple of cans of the proper stuff, even though it's quite expensive, and some more reflective dots to stick all over the bodywork so the scanner has something to kind of orientate itself on. So I'll see you again in part 2 of this video, and if we get a good 3D scan, we can print a model of the car, we can build a model wind tunnel and test it, or we can test it with some of the commercially available fluid dynamics software that mimics a wind tunnel. So why am I doing this? My car doesn't really go very fast anyway, does it? Let's be honest. So wind resistance isn't that important. I just want to see how aerodynamic or unaerodynamic it is. Obviously the area around the cockpit's not very aerodynamic, and neither is the front suspension assembly. But it'd be quite cool to see exactly how the air flows around it. If I were to put wheel spats on it, what difference would that make? I can make those out of cardboard, stick them onto the wheels, and just 3D scan the wheels. We can run the simulation again then with smoothed off wheels just to see what difference that makes. So I hope you enjoyed part 1 of this series. In the next part, if we can get some good scans, I'll try and run the model through an online fluid dynamics airflow simulation and just see how the air flows around the car. We could even 3D print a model and build a wooden wind tunnel. There are plenty of designs on the internet that we can copy. That'd be quite fun. I might do that anyway, as it's winter time now and it's pretty cold working on the car. So I'll see you again in part 2, and let's see what happens.